All right, well, thanks for showing up. I'm going to do some animation programming again. Sorry if you came here for some PUBG. That's not what is streaming right now. And I have a limited amount of time. I have about an hour, so I'm going to start on a new task. And we may not get it done, but then that'll make a good opportunity for a part 2 or part 3 of this. So, you know, what I've been doing lately is messing around with animations, right? So if I run the game for a second, you know, we've got our guy running around, and he blends animations together to do things, and we have information on the animations, and this is all stuff that we did in previous streams. So you can watch how this was built up. Now, one thing that I noticed on a previous stream is that my sort of ad hoc way of mixing animations together is not very good. You can set up situations in the animation graph where if a middle entry drops out of this list of green animations here, then we'll get a discontinuity and the model will snap. And that's not happening right now because I have the numbers set up in a way that doesn't let it happen. But that's actually just a symptom of a different problem, which is that the blending right now is not order independent, and so the results are going to vary, and that could exhibit itself later in other ways. So for example, you know, you might naturally have situations where the animator is editing the animation graph or is trying to set up blend trees, and you know, results start coming out differently for reasons he doesn't understand, and it's because for whatever reason the animation controller has added animations in the opposite order and whatever, and now they're different. And even aside from all that, just philosophically speaking, if you're going to blend n animations together, you kind of want some idea of blend. Like if it's the right idea of a 50% mix of 2 animations, it shouldn't matter which one is first and which one is second, right? Like an even blend between 2 animations shouldn't care which animation is which. It should be the same. So we're going to work toward that. I don't know if we're going to get all the way there today. All right. So I'm going to go into not the witness source. I was doing some stuff there. We're going to go into Sokoban source animation player, and we're going to change the way. So it's got this routine called eval that mixes all the animations together. And because I'm not going to maybe finish this today, but I know that I'm going to check this in so I can work on it back in San Francisco, I'm going to say new animation, or new mixing. Well, we'll set that to true for now, and we're going to put everything we do inside an if, and we'll change it back if I need to check in, and hopefully this is fine. All right, so we've got eval here, and so for every channel, if it's an animation, we do this blend factor stuff here. So, you know, you saw me edit this a little bit in a previous stream if you saw them all, but, you know, basically, we've evaluated every channel up here somewhere, yeah. So up here, we tell each channel to eval, which just means for whatever animation is on that channel and that time, figure out where what all the bone transforms are, right? So that happens in this loop. Yeah, and here we're setting up, let's make sure our current state array is big enough we did this back before we had short circuit and, so let's put that back. Let's make sure our current state array is big enough. You know, really, let's just do this. Because it doesn't make sense to be in here if we don't have these things. All right. So let's make sure I didn't break something there. You never know what's going to happen. All right. Now that each channel is evaluated, then for every channel we figure out what its blend factor is going to be, and we mix it back. So the old algorithm was a thing where we're basically calling lerp between each channel and the next one, and the blend factor just tells us how much to lerp. So it should be obvious that if you have 3 channels and you drop out the middle one, then this midpoint that you're lerping to like isn't there anymore. But you were lerping in that direction even when your factor was small. Like I don't have time to draw a graph right now, but if you had, you know, 2 animations on a line, think of them as points in space, and a third one that's like another vertex in a triangle, then no matter how low you make that midpoint, you're still going in that direction and then going to the other one, right? You're going that way and then going that way. And even if the going this way is small, it's still there. Well, maybe that's not. That's not a causal explanation of the problem. Never mind that analogy. Anyway, no time to think of a better analogy. Because in that thing that I said, it actually would, you know, as the lerp amount goes to 0, you would stay at the starting point. Yeah. Anyway, no time to think. So what we're going to do, though, is we're going to do our order-independent blend rather than this very order-dependent blend. So how do we do that? Well, the first thing I'm going to do is, so there's a couple of steps happening, right? There are blend factors where there's one factor on each channel about what its weight should be. And those right now start at 1.0. And then when we're going to mix an animation out, they go down to 0. So I'm going to start by using those same factors, and I'm going to change it to something like an order-independent blend. There are 2 complications. The simple complication is that animations start at 1.0. So if we switch this over, it'll be discontinuous immediately. So we're going to then need to ramp the mix factor for an animation from 0 to 1 as we ramp other ones from 1 to 0. So that's going to be interesting. And then the more complicated complication is we're doing an order-independent blend between n quaternions. And we're going to just linearly interpolate them, which, if you're not an expert at quaternion usage in games, you would be like, oh my god, you can't do that. They're rotations and they're not linear and you have to slurp. And oh man, what do we do? But it's actually not really true. We have to linearly interpolate them. Now, or we can linearly interpolate them, and it makes good sense for the kinds of quaternions that we're dealing with. However, the neighborhooding, so in order to blend quaternions, you do this neighborhooding operation where you make sure they point into the same half space of quaternion space. If you don't have any idea what that means, you can look up a quaternion tutorial. The problem with that neighborhooding operation is that the obvious ways to do it are order dependent, sorry. Because you neighborhood one quaternion against another one, and you can imagine a situation where you have at least 3 quaternions or more, and whichever one you happen to pick first, you know, puts you in a different neighborhood, and then maybe a different guy flips when he wouldn't have flipped, and so forth. I actually haven't sat down to work out the math to see if that gives you a wrong answer or a different rotation in some cases, but my intuition says that it does. My intuition says you can construct a case, you know, where you have like 3 or 4 quaternions, and depending on which one you pick, you'll get a different rotation as the result, depending on how you neighborhood. But there is a solution to that, which is to neighborhood against something constant that's not in your input, right? And there is already, so Casey Muratori has a video called something like quaternion interpolation in the rest pose, or something like that. And you know, he points out that the rest pose of your model defines rotations for each bone that are within the neighborhood that you consider important for that character, right? And so that's what we're going to do, is we're going to basically neighborhood to the rest pose rotation of each bone. And that's the part that I probably don't have time to do today. I probably have time to do that in part 2 maybe. So in part 1, we're just going to neighborhood to the first quaternion or something, and we're going to put a to-do, this is incomplete, you know, fix me kind of a comment there. Yes, it's called Quaternion Double Cover in the Rest Pose Neighborhood, and it's just short. It's like a 25-minute video. All right. And that also goes through a little bit more, it's not really a beginner video, but goes through a little bit more explanation of quaternions than I have just given. All right. So we're just going to start doing this, because now we're down to 45 minutes before I got to go. So I'm going to say it's called new mixing. So I'm going to say if new mixing, you know what? We're just going to replace this whole thing. Oh, my indentation still doesn't like these. Emacs, you killed me. It's not really Emacs's fault. It is Emacs's fault, because I don't want to try to program in eLisp to fix this stuff. If I could program in the language of my choice, it would already be well fixed. All right, so we're going to put that in there and there. And then paste it all in to the new mixing part. Oh, Emacs, I hate you. Sure, that works. Yeah. All right. So we haven't done anything different yet in the new mixing. Here's what we're going to do. We're going to have to rename this variable on channel, because the blend factor is not going to be just for blending out, but I'm going to call it that still. So I'm going to say factor. There's nothing worse than an auto indenter that does what you don't want. It's like it's great when it works, but when it doesn't work, it's infuriating. Ever heard of NeoVim? I'm not going to use a Vim variant, sorry. Channel.blend-out, no, factor is channel.blend-out T. By the way, this horrible behavior that Emacs is doing to me is still better than what modern Visual Studio does to me. Like, that deletes parts of my code and does all sorts of ridiculous things. So I'll take Emacs over Visual Studio. All right. Well, we're replacing it, so we don't need this comment. Whoops. We're going to iterate over every node in the channel. And okay, so we're going to accumulate. So basically what we're doing here is we're lerping into this states relative to parent, and the thing is, on the first step we assign, right? Now what we're going to do is we're going to accumulate. so first I'm going to write the accumulation. Basically, we're going to do a weighted average, right? So if you have three things with three different weights, then we multiply the value by the weight and add, multiply the value by the weight and add, multiply the value by the weight and add, and then we divide by the sum of the weights, right? This is what you do for any weighted average. The thing is, we're not in the current code initializing these to starting values because, well, because we didn't need to, because on the first step we were dropping a value in instead of interpolating. Dropping a value in instead of interpolating. We're there. So we need to do that as well, but I'll do that in a minute. First I'm going to do the blend. So this is just checking to make sure we're okay. I'm going to slim this down later because there's this weird indexing that I do that's not necessary. That'll be a good stream to get rid of that. Okay, so we don't care about if we're first or not anymore. We're just going to say I'm going to have to probably write some operators for this thing because this is a thing called an X-form state. Yeah. Plus equals this times factor, right? And then factor sum plus equals, wait, no. Here. Hold on. Hold on. Yes. So, if new mixing, factor sum is 0. So for every channel, we're going to add a sum, right? And then for every channel, we're going to mix in this. So then we get rid of all this. Boom, boom. So really, this is the only thing doing any work in this loop. This is all checking. And then this is the thing that we're drawing. I'm just going to put that for now. We're also getting rid of our weird blend factor display hack that I showed before. So, though, like I said, we have to reset our, we have to clear our states relative to parent arrays because we're not initializing them. And I'm going to do that up here. I'm going to say memset states relative to parent.data, 0 size of to parent 0 times states relative to parent.count. I put those parentheses wrong. And to do make a 0 array routine so that we don't have to keep doing this. It's pretty simple to just write a couple of line polymorphic routine called 0 array, but for some reason I always don't want to think about it. Oh, I missed another, what? Memset, size of, oh, type of. That's not a very good error message. All right, so we don't have an operator times for our X-form state. And I don't think that we also, look at all these operator timeses that we have. Quaternion, vector 4, vector 2, vector 3, matrix 4, vector 4, yeah. So, we need to make, let's look at X-form state. Where's that defined? I should put them where I define the thing. sampled animation. Okay, operator. We don't have an operator. All right. I think that's how I do this. I haven't defined an operator in so long. Let me look in math to make sure. Yep, we do it like that. Well, we're just really doing the default thing here. What I should do is have a metaprogramming thing that says, make my operator times be the times of all my members. Make my operator time. Because I think that's something we could do at user level at this point. You'd be paying a little bit of compile time because it's always going to be faster just to do this than to run a metaprogram, but it would be more adaptable and stuff. So I don't know. I don't know, man. Return result. Let's not forget that. Oops. Okay. No operator plus. Well, that's the same thing. So plus, plus, plus. Oh, no, we don't want to go plus F. We want this. Really? Oh, we don't have plus for quaternions yet. We don't have plus for quaternions yet. So let's do that. Well, this is just what happens. I also maybe want a way to say, look, it's the same as the operator for vector 4, just replace the word vector 4 by quaternion and compile it. Okay, so this is no surprise because we haven't finished the code yet. Although maybe it is. Well, all right. So the next thing we have to do, maybe it is a little bit of a surprise because I would have expected the guy to be blown out bigger than he's supposed to be, not blown out smaller. But yeah. Okay. Am I doing the right thing? So we have one factor per channel. We go over all this. Right, and then we're going to say, we don't need this first anymore. Get rid of that guy. Oh, wait, no, we got to... Hope I didn't delete some other things that I'm going to need to turn this off when it doesn't get done at the end of the hour. Okay, so still better than Visual Studio. Okay, we want to iterate over states relative to parent. I'm just going to copy it into a new value, right, for a second. Dereference that guy times scale, rescale, and then I'm just going to go. This is just going to, if I ever want to debug it or something, it's going to help me. It's going to help me inspect it. All right, so rescale is just going to be 1 divided by if factor sum rescale epsilon here. Undeclared identifier first. What, really? 226. Oh, that should be here, I guess. Yeah. Yup. All right. Hey, all right. So it's pretty good a lot of the time, and then it like blows up sometimes, which is not super surprising. Now we haven't even neighborhooded the quaternions, first of all, so that's bananas. We're not normalizing the quaternions. So, okay, let's put some to-dos in the code. So, to do neighborhood the quaternions in the lazy way. To do neighborhood the quaternions in the better way. To do normalize the quaternions. To do blend new animations inward so that we do not get discontinuities when animations start playing. Now before I do any of that, let's make sure this still works. All right, so I'll be able to check this stuff in and not freak people out by screwing up the animation system. All right, so when we do normalized linear interpolation of quaternions, you know, we're summing a bunch of quaternions and we're dividing by this rescale, but that's not going to give us a unit quaternion in the end. It's going to give us something less than a unit long. It's going to go internal to the unit force sphere, right? A chord across the unit force sphere or whatever. So we need to renormalize it. Do I have, I must have a, yeah, okay. Normalize or identity the orientation of each of these guys. Hey, that's better. So we no longer have giant dudes. So you might think, oh, a quaternion is just a rotation, man, right? So wouldn't errors in quaternion stuff just result in the guy, you know, turning in weird ways or whatever? But actually, the magnitude of the quaternion will scale something. So yeah. And then, you know, depending on how you make your matrix, well, it's a long story. But anyway, so that was responsible for the scaling. Now you can still see discontinuities here, and that I think is because of the blend factor thing. Like every time I mix in a different animation, he's gonna, so we have to fix all that badness there. And also once in a while you see his limbs flail out in a weird direction, and that may be due to us not neighborhooding the quaternions. So we're gonna take care of that next. Now I'm doing all this in a lazy way where I don't care about the performance yet, I just wanna get it working, and then I'll make it fast later. All right. Oh, someone is saying it doesn't matter how fast Visual Studio takes to start up because you only do it once a day. I disagree. I restart Visual Studio a number of times a day, in part because sometimes it crashes, in part because, you know, I'm just working in Sokoban and then I want to do this. Like say I just want to debug this by going dev-eng run tree soko debug.exe. It's like, all right, whoops. It did all that just to tell me it couldn't find the file because I'm not in the right folder, right? So let's try again. Okay, that was only a couple seconds because I was starting an empty project, but it's still, you know, it just wears on you if you do that a lot. It's just, it's not good. It shouldn't take 2 to 3 seconds for a supercomputer to open an empty window, in my opinion. I mean, I realize that I'm in the minority on this opinion, but I don't think it should take 2 to 3 seconds for a supercomputer to open an empty window. All right. I don't know what inward means here. As an intro. Okay. Neighborhood the quaternions in the lazy way. We're going to do this. We're going to say, going back here, so the scaling was a finalization operation, right? Like we can do that after we've added all the guys together, but the neighborhooding we have to do on every quaternion before we sum them. Otherwise the sum will be wrong. So let's say we do it here, right? So here's the place where we add, and I'm going to say scaled is this. I'll put this comment here. Okay, and we say plus equals scaled. Now what that's going to let us do is the following. If dot product between, and again we're treating the quaternion just as a 4 vector here. If we take the dot product of scale dot orientation and states and the destination target, if that dot product is less than 0, then scaled dot orientation, multiply that by -1 to do, this is the lazy neighborhooding we need to replace. All right, so that's just, you know, what we're doing here will be familiar to people who know about quaternions. and will not make any sense to people who do not know about quaternions. So, but like I said, there's other information. All right, so, you know, maybe that's even a little better. I don't see arms turning backward. Oh, no, we just did right there. That might be a blend factor thing then. So the thing about this neighborhooding that I'm doing is that I'm not actually sure if we're ever getting any quaternions in the wrong neighborhood to begin with. It would make sense that we might not, or that we might not get many, because we're not synthesizing anything, we're just getting input animations, and the input animations are all small joint motions. Like there's nothing where, you know, the guy is doing cartwheels or something, or where he's doing some like rotating his wrist all the way around many times. So in a human animation, you're not going to have big orientations. That, however, does not give us any guarantees about which half spaces the quaternions are in, because anyone could have changed them at any time for any reason. So what we would do is, you know, probably in our asset processing phase, when we save the animation into something very pre-baked for any specific version of the game, then we would ensure the quaternions are in the correct half space. And that'll be a good stream, actually, because our animation format right now is, let's go look at it. If I can even find it. I've shown this before, but come on, I'm going to go find one here. No, oh, because I'm looking in the wrong place. I'm just going to use the Windows search because I don't want to mess up my search settings there. See, really? It's not called sampled animation. It's called, well, this is being a good refresher for me. Keyframed animation. We changed formats at one point. All right. You know, so they look like this right now. I've shown this before, where it's just a bunch of transforms written out in text, which is fine, but it's not really the thing you want if you want your game to start up in the minimum amount of time. And the more animations that you have to load, the more this becomes a problem. So I'm going to do something where we pack these together in binary files. Now these are the quaternions, so these are positions, orientations, and scale shear matrices for you know, every bone. And these are the quaternions that could be in any particular half space, right? So this is the thing that we're possibly negating before averaging them and so on. You can see they're all over the map. So for example, here's one that's 0.711, blah, blah, blah. And here's one that's minus 0.7. You know, the other dimensions are not quite opposite this one, but they're close. So this is 0.6 and this is 0.5. And then it's sort of rotating more in this plane of these two coordinates. But anyway, if you dot product these, it's going to come out negative, I think. I'm pretty sure. Yeah. Not super negative, but kind of negative maybe. So I think I'm doing, you know, I'm maybe picking some half space at export time that is not the one that we really want. I don't know. So it's not surprising that things are weird and that we need to do this. All right, I'm babbling now. Where were we? Player. So, So the big thing is next, the blend factor thing. When we play an animation, so on the animation channel, we have blend out t, blend out duration. I'm going to change this to just a okay. Here's what I'm going to do. I'm going to say there's a blend, well, there's a blend T. It's not for blend in or blend out. It's both, right? And I'm going to say, okay, blending in is a Boolean, and blending out is a Boolean. Oh, wait. So we did this one. We did the neighborhooding quaternions in the lazy way. We're going to do the better way later. That's definitely not going to happen in this hour. So we're doing this one now. Now we may not even finish this one. All right. So blend out T is not updated here. Well, let's just compile, and it'll give us an error with whoever is. Oh, geez. Oh, geez. This could have been bad. Okay, let's make sure that still works. Oh, I don't want to get stuck having to get on an airplane after I've like destroyed the old code. I hope somebody said that in chat. Blending in and blending out. Wait, what? I just blend out T. Oh, because that's not if. All right, all right. Okay, let me try. This should work right now. Okay, we're still safe. I can still check in and go home. Okay, so line 94. Yeah, so this is just deciding when to get rid of a channel. So if we're new mixing, we do something. Else we do the old thing. And the new thing is going to be, what am I doing? If we're blending out, right, so now we have a Boolean. Okay, so we increment the blend T in either case. If it dot blend T is greater than or equal to it dot blend duration, well, if we're blending out wait, what? Okay. So this is why, so when I was explaining the triangle thing before for why we were getting discontinuities, I was like, wait, no, we wouldn't get discontinuities because of that. And we wouldn't, but what's happening here is we're doing a non-ordered. Oh no, we're doing an ordered, okay. I don't know. I need to think about that. Doesn't matter, because we're doing order independent blending. Doesn't matter. So, yeah, I mean, keeping the animations in the same order when one disappears from the middle might be a good enough reason to do an ordered remove from this array instead of an unordered remove. Maybe this is just a sign that I need to make ordered remove in the language be as easy as unordered remove. We'll see. Okay. You know, we're doing an ordered remove, so we have like a target index, and as we sweep along the array, the target index goes with us. But if we continue early, then we don't increment the target index right down here, which means then our next guy gets dropped into that. So we're doing an ordered remove basically by sweeping across, and yeah. If you've done this before, you know what I'm talking about. If you've done this before. So we're doing an ordered remove as we iterate over the array that we're iterating over anyway, so it makes it, you know, not be an expensive operation, whereas normally it would be because you'd have to like copy all the elements back. That is what we're doing here. So if we're blending out, else assert that we're blending in, and we're no longer blending in. We finished our blending in. All right. This is, okay. I'm going to say if new mixing, whatever. Come on. Indent me, indent me. Thank you. Indent me too. Blend out T. So if channel dot, if we're not blending in, so this is just saying, look, if we're going to play a new animation and we're already playing it, then just, you know, blah, blah, blah. Otherwise, I'm going to factor this into something called start blending out. So otherwise, so if the channel, if we're going to play an animation, you know, I think that given the way the new system works, we do not need to do this anymore. Oh God. All right, okay. So, you know, it used to be like, okay, if you say you're playing a new animation and there's an old channel. You know what? I don't think we need any of this. So all this code is to let animation be driven by what I used to do, which was just programmatically say, play this animation on the guy, play that animation on the guy. But that's not how it works anymore. We have this animation control system that does this sort of thing at a higher level, although frankly, I'm not completely sure now that I take this out. We're going to see. Okay, so this is one of those things. Okay, I'm going to put a new to-do. To-do. Explicitly start blending out any pre-existing animations when we transition to a new animation control state. So I think I might be doing that already, but if I'm not, regardless, the right place to do this kind of like, oh, let's start magically turning off old animations because we played a new one. The right place to do that is at the higher level control system. It is not here, which has now become the lower level thing. You don't want the lower level thing invisibly assuming things about how you want the animations to behave. And with that, I think I'm out of time for now. So like, I'm just going to leave it here so that I remember where I was. I'll also do a comment. To do, as a subset of this, is make blending out work again with the new variables anyway. Okay, so now my goal is just make sure that I didn't break anything, and then I'm going to check in my code. And we'll continue this at a later date. Does anyone have questions for just like a couple minutes about what the heck I'm doing, or why, or anything like that? In progress work on new machine. Anyone? Anyone? What advantages does this have over the old system? The advantage is that it is better defined. It is not an ad hoc blending of animations that depends very specifically on the order in which you chose to blend them. You know, like I said, a reasonable interpolation operator doesn't depend on the order of the things in which you're interpolating, if you can help it, right? I mean, there's some mathematical aspects about sometimes when you go to higher dimensions, you start losing these kind of nice mathematical properties, but while we can get them, we should get them because they're good. So like I said, you know, we don't want to end up in a situation where the animator is sort of arbitrarily changing the file and then getting changes in the output that he doesn't understand, you know, because he copy and pasted one thing from one place to another place, and now that happens to make things happen in the opposite order and the blend comes out different. We want to minimize that kind of surprises. So that's what we're doing here. Can I give a 10-second Cliff Notes version? No, because the stream is about to end and I'm about to get on an airplane. What is the difference between an ordered remove and an unordered remove? So the fast way, if you're going to remove an element from an array, like you're iterating over the array, or even if you're not iterating, you're just going to remove an element from the middle, then what you do is you take the item off the end and drop it in the middle and decrement the length counter on the array so that the copy of the guy on the end that you just dropped on the middle, nobody will look at anymore, right? That's the fast way to remove an element from the middle of an array. The problem is that it changes the order of elements in the array. And so if you care about the order of elements in the array, that's bad. So, you know, in many cases, in the vast majority of cases, I do not actually care about the elements in the array, right? I'm using the array as something like a set where I just want the members of the set, but I don't have a concept of order. But in this case, probably I did care about the order, and so I was doing a more complex ordered remove that the compiler doesn't really help you with, so I had to do it in user code the regular way. Can I show the new animation discontinuities with 1/16 speed? Not really. I mean, let's do it for a second. Oh, no, because I have it turned off. Nope. I got to go. Where did you get the graphics? Did you get it designed for this project? It looks good. Yeah, I mean, we've got a team working on it, and these are not final graphics by any means. They are placeholders. But they're working towards final, right? We're trying to get the feel of the game nailed down. The rendering in this particular program is not even that good yet. So given these assets, if I were to work more on the rendering, they would look better substantially. All right, everybody, thanks for coming by. Sorry for such a rushed stream, but I'm trying to pack one in when I can. And we'll continue this at a later date. Thanks for coming by.